Welcome to Mastering Solutions. In this problem, let's draw a picture because getting it set up correctly is half the battle with this one. Okay, so we have our picture here. Now, what is the question saying that the angles are here? They say that the underwater diver sees the sun 50 degrees above the horizontal. So above the horizontal for the diver would be right here. And so this angle, we'll say this is phi. This is 50 degrees. So now we have air and we have water, so we could put in our indices of refraction, 1.33 for the water and 1 for the air. And so this right here would be our normal. Now remember, it's very important, whenever we're dealing with Snell's law, the angle is always from the normal. So this angle right here, we could say is theta, and we'll say it's theta sub W for theta of the water. And then the sun is coming down like this. And this right here, we'll come back to in a second. This is from the normal for the air. So this is theta for the air. And so the angle that the light is coming in from the sun, this is the same angle for the fisherman, right? That's no different. And so this angle right here is also the exact same one, the theta for the air. And so we know that we're going to be using Snell's law, but looking at the question, what is it that we need to find? We need to find how high is the sun above the horizon to the fisherman. And so this angle is what we're going to be using Snell's law to find, but that's not the answer. That's where a lot of students will plug in the answer and get it wrong. This angle here is what we're trying to solve for. We'll say theta F for theta final. And so what is Snell's law? Well, of course, Snell's law is N1 sine theta 1 is equal to N2 sine theta 2. Now we can say N1 is air and N2 is the water. It doesn't particularly matter. And so let's substitute these for the air and the water. We'll say this side is air, and we'll say that this side is water. And so we're trying to find the theta for the air. So we can divide both sides by N1. So we have sine of theta 1 is equal to N of the water times the sine of theta for the water. And we'll say this instead of 1 is air. And now to isolate theta air, we take the inverse sine, of course. So inverse sine of N water sine theta sub water all over N of the air. And this is N air. Now it's 1, obviously, so we don't have to put it in, but just to show you the algebra, that is the correct equation. So now when we plug in our numbers here, let's come over here so we have some space. So we have theta air is equal to the inverse sine of the N of water is 1.33 times the sine of the angle. And they say that this angle is 50 degrees here, but that's not the angle that we need to put in because we have a right triangle. So this is 90, 50. So we need these two to add up to 90 so that the whole triangle here adds up to 180. So 50 plus 40 would be 90. So this angle here is 40 degrees. So sine of 40 degrees, and that's all over 1, like we said. So plugging that in, we have inverse sine of 1.33 times the sine of 40 degrees. We're in degree mode. And so we have 58.7 degrees. So this is 58.7 degrees. And remember, we are finding from the normal out to the ray, that is the angle that we just found. This, of course, is 90 degrees though, and so to find our answer of what is the angle above the horizon for the fisherman, we take 90 minus the angle we found. So 90 minus 58.7 degrees will give us our answer, and we have 90 minus 58.7 gives us a final answer of 31.3, so we could round that to 31 degrees. So using Snell's law, this is the answer to the question of 31 degrees for the fisherman, as how high he's seeing the sun above the horizon.